Got it. Okay. Share my screen. Okay. Let's start here. So, welcome, gentlemen. We're at the end of week 10, right? So, only real reminder is week 12. We're anticipating exam 3 over, I think it's chapter 6, right? So otherwise, it's the usual announcement. So we're just gonna go ahead and hop into the material for the day. So I know last time we had already started on the homework, so we'll get through this as best we can. We might go ahead and do the quiz, and we'll see what it looks like. We'll see what it looks like when we're done. We're asked to find the common difference in the nth term an of an arithmetic sequence whose fourth term is this and 15th term is this. Okay, so let's take some notes. Let's write some things down. Let's see, we can get rid of that. Let's get a screenshot. Let's see. Go like this. Does that help any? A little bit. Okay, hopefully that doesn't look too terribly weird. So let's get a copy of this guy. And we're gonna drop this copy over Notability so we can take some notes. But there's a setting that I can update. That's okay. Templates. It's okay. All right. So let's see. Common difference of an arithmetic sequence. So, okay. If we're working with an arithmetic sequence, then we might use the nth term of an arithmetic sequence is going to be the first term plus n minus 1 times the common difference. So they're asking us to solve for the common difference. It says the fourth term is 13. So when n is 4, so we can say, and it says fourth term, okay. So they didn't give us any information on the first term. When n is 4, we don't know the common difference, but the output is 13. And then the other piece of information that was given, when n is 15, so I don't know the first term, we don't know the common difference, the output is 68. Okay, so we use the nth term of an arithmetic sequence, right? And then we plugged in what was given. When n was 4, the output was 13. When n was 15, the output was 68. So then we have two equations. We have two unknowns so that we can solve the system of equations, okay? Let's see. So we might start by, we can distribute, or actually, instead of distributing, we can just combine like terms, right? So then we'll get, I'm going to rearrange it as well. We'll get 3d plus a1 equals 13. And then 14d plus a1 equals 68, okay? Okay, so one of the techniques for solving a system of equations like this, you can multiply one of the equations by a non-zero real number and then add them together. So I basically, this is called the elimination method. I want to get rid of this a1. So what I'm going to do is distribute a negative across the top. So this becomes negative, this becomes negative, this becomes negative. I basically multiplied that row by -1. So now when I add these two equations together, the a's cancel. So these guys cancel each other. 14 minus 3 is what, 11? So that's going to be 11d equals, let's see, that's a 5, 55. Divide both sides by 11 and d equals 5. Okay. So then if we solve the common difference, we need to go back and solve for A1. So I'm going to plug this in the first equation. So then that's going to be 3 times 5 equals 13. So what is that? 15, A1 equals -2. So then our general term is going to pick on the form -2 plus n minus 1 times 5. But I think that the question only asks for the, well, right now it only asks for the common difference. So I'm just gonna, and we could check and verify that our formula works for those, but for the sake of time, I'm just gonna submit result of 5. And if it's wrong, I'll go back and try to find the error. Okay, if I hit 5 and enter. Okay, the nth term of the arithmetic sequence, the nth term an of the arithmetic sequence. Okay, so we need to keep going. There's this guy, so we just need to simplify it. So an is going to take on the form. We got this -2 plus 5n minus 5. And basically there, I distributed the 5. Combine like terms. An equals 5n minus 7. Okay. So that should be the nth term. So any term that we want, this should take us straight there, right? And we can verify it if we compare it to what was given originally. I think I'm gonna shrink this down just a little bit, just to get it to fit. Okay. So then, again, when n is 4, the output should be 13. 5 times 4 is 20, minus 7 is indeed 13. And then when n is 15, the output should be 68. So 5 times 15 is 50 plus 25 is 75. Minus 7 is indeed 68. Okay. So this an works for both. So we got 5n minus 7. So I'm going to go here and type 5n minus 7. Okay. So that was an adventure. I have that it is essentially that time, the 15-minute mark. So let me check for any latecomers. Okay, let me note that. So I got this student here. Okay, let's keep going. Okay. All right. Find the common difference and the nth term of the arithmetic sequence. Okay, so this is kind of a repeat. 13, 10, 17, and 9. I guess I can screenshot it. I was going to try to just memorize those numbers quickly, but it's just this is a lot easier. Take that. I'm going to drop it here. And let me just resize it so that we can see it. Okay. I mean, I guess we can try it. I don't know how I feel about that, but it's fine. Okay, arithmetic sequence, all right? So again, we're starting with the general form of arithmetic, A1 plus n minus 1 times the common difference, right? So that was what we talked about last time. Let's see, whose 13th term, all right? So when n is 13, output is going to be 10. This comes down, that comes down, minus 1, everything else comes down, right? And then the other one was the 17th term is 9. Okay, So this is a repeat just with different numbers. Okay. If we combine like terms and simplify, A1 comes down, that becomes what, 12D equals 10. And then we get A1, 16D equals 9. I'm going to multiply the first equation by a -1. So essentially this becomes negative. I'm multiplying this row by a -1. So that way, when I add these two equations together, the A's cancel out. So this is going to cancel this. We get what, 4D? Looks like it equals -1. Divide both sides by 4. D equals a -1 by 4. Okay. Okay, that's what we get. That's a +4. That's a -1. So then I'm going to use, I guess I could use either one. I'm going to use the first equation to solve for A1. So I'm going to take that result that we got, and if I plug it in, then 12 times a -1 by 4 should equal 10. So 12 divided by 4 is what? 3. So that's going to be a -3. So then A1 equals 13. So then the general form is going to be 13 plus n-1 times a -1 by 4. Okay, that looks a little bit nasty, but that's how it is for now. If we simplify, minus n divided by 4 plus a quarter. (40 plus 12 is 52. So 53 over 4. Okay. I think that this is our nth term here. Now we can check it before we submit it. Let me see. Let's compare it. Let's compare it to what was given. Let me see. I think I'm gonna use my calculator. So now the an that we got, I'm gonna type it as a function. We got negative, instead of n, I'm just gonna put x divided by 4 plus 53 over 4. Okay. So then when n is 13, the output should be 10. So I'm just gonna call on that function. When n is 13, the output should be 10. When n is 17, the output should be 9. All right, that's about the best we can do, okay? We confirmed that this worked for the given information. So we got negative n over 4 plus 53 over 4. Did I lose my page? Oh no. Oh, there it is. Okay. I see what's going on. And then we just, I guess we can, n over 4, negative n over 4 plus 53 over 4. We got negative n over 4 plus 53 over 4. Okay. Let's see. Oh, common difference. I'm just putting answers, not even reading the instructions, right? Moving too fast. Common difference we got. Was a -1 by 4. Okay. And then the nth term, I think we got negative n by 4 plus 53 by 4. Okay. Let me just check on you guys in Zoom. Looking good. Okay, that's interesting. Let me let him in. On to the next question. I need to note that before I forget. I just let in.
Sir.
All right. Yes.
Can you look at my screen? I did a problem and it keeps saying I got it wrong, but I'm sure that
Was it in the homework?
it's on the one you're doing right now.
Question number 10.
It's number 7.
Click on the Ask My Instructor and let me pull it up.
Where is that?
You see in the bottom left where it says Get More Help?
Yes.
You click on that and click on Ask My Instructor, and it'll send me a screenshot of your very question, and I'll pull it up right now.
Do I click video or text? Oh, ask my instructor.
Yeah, Ask My Instructor, yeah. Find the sum.
I sent it.
Okay. So if you can see this, it's for other people, it's a good idea to give this one a go and see if you can get the result while I pull up this other one, this request. So then here, Mr. Okay, got you. Let's see. Okay. So this one says, find an expression for the nth term of the following. Okay.
Does it show you my answer? Or
I see what you have. It doesn't show the answer just yet, but let me pull it up. And I'm going to share right here. Let's go here. I'll drop it. This one. I think it was this one. Add. Cool. All right. So yours should be this. Let me just make it so you can see it. Okay. It says find an expression. Let me why is it like that? Let me crop this. That's good. Okay. So it says find an expression for the nth term. So if it's arithmetic sequence, right? So we would start with an, come on. An equals the first term plus n minus 1 times the common difference, right? So if it's arithmetic, let's see if we see that the first term is a -8/7, right? So the nth term, we got the first one, which is a -8/7.
Oh, I see the problem. Actually.
It's a different problem?
No, so I see why I got it wrong.
I see, okay. Do we need to finish it out or you can take it from here?
You can finish it out.
So we get n minus 1, the common difference, right? Okay. So we need to basically say the second one minus the first one and just confirm that it works. Let's see, can we just pull this here? That's not the right one. This one. And then this one. Thank you. Stop. Done. You can delete that screenshot. Okay, cool. So then if we say -2 minus parentheses -8/7, and I'm gonna say math as a fraction, it looks like the common difference is a -6/7, right? So it looks like we're adding -6/7 at each step, right? And we can confirm. So if we start with a -8/7 plus -6/7, math as a fraction, we should get -2. And then if I say plus -6/7, math as a fraction, yada, 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 right? So then from here, you have one equation. Well, just simplify. You're not even solving. You can just simplify from here, right? Combine like terms, distribute, stuff like that. Like this guy can distribute. we have this negative 8/7 minus 6/7n plus 6/7, combined like terms, negative 2/7. I think that's it. So just try that. If that doesn't work, we can talk about it more. Okay.
Okay.
All right. Let's see. So we left off here. Full screen. Come on. Thank you. So find the sum. Did we get a copy of this one? Oh, that was that one. Okay, so let's get a copy. Let's get a screenshot. Let's crop. Okay. And then we're just going to take that and drop it right here. Boom, just like that. All right. And let's just expand this so that we can see it. That's good enough about there. Okay. All right. So find the sum of the following arithmetic sequence. Okay. So a couple of things here. Since we're working with the arithmetic sequence, it's a good idea to start with the general term of an arithmetic sequence, which is the first term plus n minus 1 times the common difference. Last time we also came to a conclusion for the sum of the first n terms of an arithmetic sequence. So the sum of the first n terms, let me see. I remember that technique. That happened n times. Okay. So I think it was like, I think it was the first term plus the last term times n all divided by 2. All right, I think that's what we said last time for this. Undo. See, I don't like that feature, whatever feature it is. They I mean, it's fine where it is. Okay, let's go with it. All right. So I think these are some of the things that we said last time. Hopefully my formulas are good. I don't. I'm gonna just go with it for now. Okay, so we have the first term. We need to figure out what n is. Let's see if we can get our expression for a sub n. Let's see. So our first term is 7. We still don't know what n is. Common, now if it's an arithmetic sequence, the common difference, it looks like we're adding what, 4 each time? So our common difference is 4. Okay. So then if we want to solve for n, if 7, notice, if 7 is when n is 1, 11 is when n is 2, 15 is when n is 3. So then if we want to solve for n, we need to see what n is associated with 43, right? So then we're going to put 43 here. And so at this point, we have one equation, one unknown, we can solve for n. Okay, so we can start by distributing this 4. Okay, I'm kind of liking my little colors at the top there. It's working for me. It's convenient and it's not disrupting my writing. That's what I like about it. Plus 4n minus 4 equals 43. Okay, combine like terms. That is what? 7 minus 4 is 3. So then on the right-hand side, you get 40. On the left, you got 4n. So then n is 10. Okay. So when n is 10, the output should be 43. So we have n. Let me highlight the key information. All right. Let's do this color. All right. So we found that n is 10. Our A1, we can put it, I guess we can highlight it here, is 7. AN, the nth term is the 43. So that's this guy here. I think we have everything that we need to answer the question. So the sum of the first n terms. So to kind of recap, the sum of the first, I guess in this case, it's going to be 10 terms, is going to be, let me change that color. So the sum of the first 10 terms is going to be 10, provided our formula is correct. The first term, which is 7, plus the last term, which is 43, all divided by 2. Okay. Let's see. So that's essentially going to be 5 times 50, 250. That's so interesting. Like how we're able to jump to these conclusions based on, that's called induction, right? In mathematics, when you're given like a few pieces of specific information and you can essentially generalize, you can jump to any other piece of information based on a few initial conditions. That's called induction. Versus deduction is where you're given general information and you can jump to any specific piece of information. Right? But it's just interesting. You'll hear people like the famous detective Sherlock Holmes, Elementary, My Dear Watson. It's deduction. So like we're doing it with numbers, but you can do this for like scenarios. And like this is, so the reason it's interesting to me and I'm excited about it because like I think about like lawyers, they make easy 6 figures, right? Being a lawyer is really just a personification of mathematics, because in the court of law, you have to prove beyond a reasonable doubt, beyond a shadow of a doubt, that either the person is guilty or the person's not guilty. And so a lot of the techniques that they use are actually things that we talk about in here. It just doesn't seem like it. It's very like disconnected, but the techniques that they use parallel or very similar or piggyback or derive, they essentially come from what we're talking about amongst here, right? If you don't have that sense of like induction versus deduction, you wouldn't make that connection, but that's exactly what they're doing, like in some cases, right? So anyway, it was just interesting, any reason to get excited. That's what keeps me going, just to have fun and figure stuff out. Okay. So we got 250. Let's submit it. Hopefully our thing is still there and, we can work with it. If we get it to load and it didn't change, it booted us out. Okay, so we might have to redo it. That's okay. Let me see some. Come on. Let me close this out. Allow. And we're working on week. This one. Right here. We got a solid 10 minutes. Now, at the pace that we were going last time, I thought that we were just gonna like breeze through this and finish it. Nope, it's still taking up the whole class time. That's why I was trying not to get you guys' hopes up. I think we got to redo it. So I'm just gonna take this and just redo it because I think the numbers have changed. I'll keep this information. And here, come on, drop this here. I'm just going to redo this really quickly. 6, 11, yeah, the numbers have changed. So let me just redo this really quickly. All right. Let's see. Arithmetic sequence, right? So let's just do it again. The nth term is the first term plus n minus 1 times the common difference. The sum of the first n terms is going to be n times the first term plus the last term all over 2. Okay, we kind of talked about where that came from. Let's see. So if we plug in information that we're given, we need to find n. Okay, so the first term is 6. We're trying to solve for n. Common difference looks like it's 5, right? We're adding 5 each time. Okay. And the nth term is 41. So we want to see, okay, what term is 41? Okay, if we go ahead and solve, like we can distribute this 5, combine like terms. So then we'll have 5n minus 5 plus 6 equals 41. That's a 1, subtract 1 is 40. 5n. So then n equals what? 6, 8. 8 times 5, right? Okay, so then the sum of the first 8 terms is going to be 8 times 6 plus 41 over 2. Okay, that's a 4. What is that? 47. 160 plus 28 is 188. Okay, so when we did it this time, we got 188. When your mama tried to skate. Okay, let's submit this and let's see what we get. That was a repeat of what we did before, just with different numbers. Oh, come on. Settings, turn this off. Right, we got 188. Cross our fingers. God is good. Okay. All right, that was an adventure. Let's do another one. We got time for one or maybe two more. Okay, let's go ahead and do this one. It looks very similar. Okay. We just did a speed run of that one. Let's go ahead and knock this one out as well. About here. And it's interesting, like Mike. Okay, so I still game. And I actually use like, I mean, I don't break up baiting, like different techniques. And like I kind of want to study like how math has been applied to the game of chess and strategy and stuff like that. But I want to use it for my video games to just dominate the games. But then where I am now is like, okay, I need to figure out how to stream better. I don't know if I just need a more powerful device. I gotta like sit down with a professional and talk to them and say, hey, how come my streams are laggy, and like how can I make a crisp live stream and stuff like that? I probably just need a more powerful machine. That's just my first thought. Okay, find the sum. Okay, so basically they're asking us to solve for Sn like we did before. So we were using two main pieces of information. The nth term, come on. The nth term is the first term plus n minus 1. And I'm doing this from memory. I keep writing it because that constant repetition helps to ingrain it in my memory. N times a plus the first term plus the last term over 2. Okay. So we got to solve for n like before. So we can solve for the nth term. The first term is 8. We're solving for n. Common difference. 4 and 2 is 6. So it's like we're adding 6 each time. And we're trying to solve for n. So 86 is we're trying to find out which term that is, right? We're trying to solve for n for 86. Okay. So just like before, solve for n. You have one equation, one unknown. We can solve. We'll get like 6n minus 6 plus 8 equals 86. That's going to be a positive 2. So when we subtract it, it becomes 84. 6n, n equals, let me see, there's a 1, 24, so it's 14. Okay. All right, so we solve for n. We got the first term, last term. So now we can solve. So the sum of the first 14 terms is going to be 14 times 8 plus 86, all divided by 2. So that's the same as 7 times 4, 94. Okay. 7 times 9 is what, 63. So 630 plus 28, 658. Okay. If anything is not clear, you just have to let me know. I'm just trying to get some in there before we run out of time. Let's try 658. That's not right, then, we'll just go back and try to figure it out. 658. Okay. We got a solid 5 minutes. Let's keep going. Let's do at least one more, maybe 2. Let's knock it out. All right, it's the same thing as what we were just doing, just different numbers. So it's essentially another speed run. Okay. All right, that's fine. We want to take this, drop it here. Boom. Okay. All right. Okay. Same deal, right? So notice, like with these past three examples, we're doing the same thing. Come on. We're doing the same thing, just with different numbers. The first term plus n minus 1 times the last term, and then the sum of the first n terms is going to be n times the first one plus the last one all over 2. Okay, so far this has been working. Okay, if we plug in what we're given, the first term is, let's do it here, is 6. We're solving for n. Common difference looks like it's 4. We're adding 4 each time. And we want to figure out which term 58 is. Okay, so same as before. Okay, we're going to get 4n minus 4 plus 6 equals 58. Okay, that's a 2. So if you subtract it, it becomes 56. 4n, n equals, that's a 1, 14 is 4, right? So it looks like n is 14. So then we want to find the sum of the first 14 terms. It's going to be 14 times 6 plus 58 all over 2. That's going to be 7 times 64, 3642 plus 28, 448. Okay. So I tried to show like pertinent information and write out some of my inner thoughts so that you guys can see like what I'm thinking. Hopefully it makes sense. 448. Come on. Come on. Did you lose my work again? Why do you keep logging me out? What's wrong with you? You are tripping. Oh, that's annoying. Okay. I'm gonna have to relog in. I'm pretty sure usually when that happens, I guess maybe before I leave, I should try saving it. So that way I won't have to start over. Because if I save it before I leave, even if it kicks me off, it'll save the work and it won't change it. I have to just be aware of that. Because now if I try to go back, the numbers will change. It doesn't always change. Most of the time it does. Yeah, I think those numbers did change. All right, I'm gonna do it one more time. How do I hit save? How do I do that? Save, there it is. Let me just hit save before I leave. And then now let's go back. And maybe I should just save it each time. That way. Yeah. I'm gonna do it one more time. Just to see how fast I can do it. And if the numbers are the same, then we can use our previous result. But I don't think these numbers are the same. And I did hit save, so it should be okay. Oh, no, they're not the same. Okay. All right, this will be it. But win, lose, or draw, because that's time. So this will be the last one, win, lose, or draw. Okay, one more time. So the nth term, I'm still doing that thing, an, the first term plus n minus 1 times the last term. N times the first term plus the last term all over 2. Thank you. No. Okay. Let's see. So we got 13, n minus 1. It looks like the common difference is 5. Yeah. Okay. And we want to solve for n when the output is 63. So then we'll get 5n minus 5 plus 13 equals 63. 5 and 3 is 8. So if you, okay. So then subtract 8, 55. It looks like it's 55. So then n is 11, okay? So then the sum of the first 11 terms, 11 times 8 plus 63 over 2, okay? This one's not as clean as the last. 11, what is that, 7? So 71, yeah. 71 over 2. I was kind of hoping one of them would be even so I can cancel them. Okay. So that's going to be 710 plus 71 over 2. Okay. So that's a 1, that's an 8, that's a 7 over 2. Okay. Stop, go away. 3, 9, 5.5. I think that's it. 395.5. Oh, I'm not confident in that one. No, let me see. That can't be right. Three and 2 is 5, right? I feel like we made some mistake because I don't think we should get a fraction, right? Maybe it's not 11. Let's look at it again. N minus 1. Okay. 13 plus n minus 1 times d equals 63. 5n minus 5. 5 and 3 is a positive 8. You subtract. Let's get 55. It looks like n is 11, right? The sum of the first 11 terms. 8 plus 63 times 11 over 2. That's 71. 710 plus 71. I am doing something wrong somewhere. Something is off. $781. We got 395 and a half, but I'm not confident in that. 395 and a half. Yeah, the formula's right. And did I write it right? Let me check it again. $73 minus 2, 71. Hey Siri, what's 11 times 71?
11 times 71 is 781.
I don't know where I'm going wrong here. Let me see. Common difference is 5. Okay, 5n minus 5. It's an 8. It's a positive 8. Subtract 8. Hey Siri, what's 63 minus 8?
63 minus 8 is 55.
And that's 11. Hey Siri, what's 11 times 8 plus 11 times 63?
11 times 8 plus 11 times 63 is 781.
I'm not sure what I'm doing wrong here. Find the sum of the following arithmetic sequence. Let me think one more time. Let me give myself like another minute or two. Oh, I see what I'm doing wrong. Jesus. See, I knew there was something like that was gonna happen. I found a mistake. Doing the wrong A1, right? This guy right here is supposed to be 8. So that's throwing everything off. Let's try it one more time since we found a mistake. Let's copy. This should be it here. Because we're trying to go fast. Who wants to go fast like Ricky Bobby? I want to go fast, right? Let me just wrap this up and get you guys out of here. Try one more time. Okay. So n terms, the first term plus n minus 1 times d. N terms, n times the first plus the last divided by 2. Okay. The first term is 8. N minus 1. Common difference is still 5. Okay. And 63. Okay. So then we get 5n minus 5 plus 8 equals 63. That difference is a positive 3. You subtract 3, you get 60. 5n. So then n equals 12. Okay. So then the sum of the first 12 terms, 12 times 8 plus 63 over 2. Okay, that's better. Because when I got a fraction, I was like, you can't add up whole numbers and get a fraction. I was like, something's wrong. I couldn't figure, but we found it. That's going to be 6 times, what is that? 71. Okay. 36, 420 plus 6, 426. Okay. So that's the trouble with going too fast, you know, that kind of stuff happens. But again, I'm just trying to get you guys out of here. Okay, feel better about that. 426. Right here, come on. It's fine. 420, nope. Just go away. Oh. Come on. All, get rid of it. 426. All right. We got to the bottom of it. That was an adventure, okay? So just a lesson in like moving. That's, you know, when you move too fast, yeah. It's fine. We just was missing the first term. Okay. We are well past overdue. All right. Are there any burning questions? Let me go ahead and make a copy of my notes available for you guys. Fall. Nope, not calendar number 1. This is calendar number 2. Into the note section, updated daily. This is week 10 on Wednesday. You can send it there. When this bar finishes loading, you'll get a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace. Let me check the chat really quickly. Yeah.